You think you want to know why magnets repel. But you don't, not really. What you want is comfort. You want me to connect this invisible force to something familiar, something that makes sense, something that lets you stop feeling confused. And I'm not going to do that. Not because I'm being difficult, not because I'm hiding behind jargon, but because the question itself is broken. And until you understand why it's broken, every answer anyone gives you, including mine, is going to leave you frustrated. Here's what I'm going to do instead. I'm going to show you how your intuition has been lying to you since childhood. I'm going to reveal that everything you think is solid isn't. And I'm going to prove that the mysterious force pushing these magnets apart is the exact same force that's holding you together right now. By the end of this video, you won't have a comfortable answer, but you'll have something better, the truth. Let's be honest about what happens when you ask, why do magnets repel? You're not asking for information, you're asking for translation. You want me to say, magnets repel for the same reason that, and then fill in the blank with something you already understand. Rubber bands, springs, two hands pushing against each other, something comfortable, something that lets your brain relax and say, oh, I get it. It's like that thing I already know. Here's the problem. There is no familiar thing. Magnetic repulsion is fundamental. It's rock bottom. There's nothing underneath it to compare it to. You're asking me to explain electromagnetism by comparing it to something simpler. But there isn't anything simpler. That's like asking me to explain arithmetic using something more basic than numbers. Can't be done. The foundation is the foundation. You can't stand on something beneath the ground floor. Now, you're probably thinking, but I've heard explanations. Magnetic fields, electron spin, virtual photons. Those sound like deeper explanations. No, they're descriptions. Very precise, mathematically rigorous descriptions. They tell you how the force behaves, not why it exists in the first place. And you need to understand the difference between those two things, or this entire conversation is worthless. How tells you the mechanism. Why asks for philosophical justification. Physics gives you how. The universe doesn't owe you why. Let me prove my point. Right now, push your hand down on your desk. Go ahead, I'll wait. Push hard. Feel that resistance? Why doesn't your hand go through? You'll probably say, because the desk is solid. Wrong. Not wrong because the desk isn't solid, it is. But wrong because that's not an explanation. That's just another label for the thing you're trying to understand. You've renamed the mystery, you haven't solved it. Try again. Why doesn't your hand pass through? Because the atoms are packed together. Better. Keep going. Why don't the atoms in your hand pass through the atoms in the desk? Because atoms are solid too. No, stop. Think about what an atom actually is. An atom is mostly empty space. If you scaled an atom up to the size of a football stadium, the nucleus would be a pea at the center. The electrons would be tiny specks way out near the seats. Everything in between? Empty. Your hand is essentially all empty space. The desk is essentially all empty space. So why don't they pass through each other? You're getting uncomfortable now, aren't you? Good. That discomfort is your brain realizing its everyday intuition is completely wrong. The answer is electromagnetic repulsion. The electrons in your hand and the electrons in the desk have the same charge. Like charges repel, when you push down, you're feeling trillions upon trillions of tiny electromagnetic interactions, all adding up to what you call solid. And here's the question that's going to break your brain. Why do like charges repel? You can't answer that, can you? You can say, electromagnetic force, but that's just giving it a name. That's not explaining anything. It's circular. It's like saying, magnets repel because of magnetic force. You haven't explained anything. You've just moved the mystery one step over. The electromagnetic force is one of 4 fundamental forces in nature. Not caused by something else. Not derived from something simpler. It just is. And here's what nobody tells you. The force that stops your hand at the desk surface is the exact same force that makes magnets push apart. The same force. Not similar. Not analogous. Identical. The electromagnetic force. So why does one feel obvious and the other feel mysterious? I'll tell you why. You've been pushing on solid objects since you were 6 months old. By the time you were 2 years old, your brain had built up a massive library of experiences. Pushing, grabbing, falling down, hitting the ground. Your neurons literally wired themselves around those experiences. They built patterns, expectations, an entire intuitive framework. So now, when you push on a desk, it feels normal, natural, obvious. You don't think about it. You don't think it needs explaining. It's just how the world works. But magnets? Magnets push through empty space. You can see the gap. You can slide a piece of paper through. There's nothing there. That feels weird. That feels wrong. That feels like it demands an explanation. But here's the truth that's going to change how you see everything. The weirdness is in your head, not in the physics. When you push on the desk, the electrons in your hand never actually touch the electrons in the desk. They repel at a distance. A tiny distance, a few atomic widths, but still a distance. We call it contact because the distance is too small to see. But it's not really contact. Nothing is touching. It's electromagnetic repulsion operating across a gap. With magnets, the gap is bigger, a centimeter, an inch, big enough to see, big enough to make you uncomfortable. But the force is the same. The mechanism is the same. The only difference is scale. The mystery you feel is not a mystery in the physics. It's a mystery in your psychology. You're comfortable with electromagnetic repulsion at atomic distances because you've experienced it your whole life. You're uncomfortable with electromagnetic repulsion at centimeter distances because it's less familiar. That's it. That's the whole difference. The entire mystery exists in the gap between your intuition and reality. Now you're thinking, okay, fine, but surely quantum mechanics explains why the electromagnetic force exists. Wrong. Again. Quantum electrodynamics, QED, the quantum theory of electromagnetism, is the most precisely tested theory in all of science. We've measured certain predictions to 11 decimal places, and the theory matches exactly. 11 decimal places. That's like predicting the distance from New York to Los Angeles to within the width of a human hair. But here's what QED does. It tells you how to calculate electromagnetic interactions with absurd precision. It gives you rules, equations, predictive power. What it does not do is tell you why the electromagnetic force exists in some deep philosophical sense. It describes the force beautifully, perfectly. But it doesn't explain it away. It doesn't reduce it to something simpler. Because there isn't anything simpler. Here's what really bothers me about the magnet question. You're treating magnets like they're special. Like they're the one weird thing in a universe of normal things. That's backwards. Everything is electromagnetic if you look closely enough. Why do chemicals react? Electromagnetic forces rearranging electrons. Why does light bounce off mirrors? Electromagnetic interaction between photons and electrons. Why do you see colors? Electromagnetic radiation hitting electromagnetic receptors in your retina. Why does your computer work? Electromagnetic forces moving electrons through circuits. The electromagnetic force isn't some exotic phenomenon that only shows up in magnets. It's everywhere. It's the dominant force in your entire life. Gravity? Weaker by a factor of 10 to the 36th power. Completely irrelevant for atoms and molecules. The strong and weak nuclear forces? Locked inside atomic nuclei. Too short range to affect anything you can touch. Everything else, and I mean everything, is electromagnetism. The force making magnets push apart is the same force holding your body together right now. The same force preventing you from falling through your chair. The same force letting light bounce off this screen so you can read these words. So when you ask me to explain magnetic repulsion by comparing it to something normal, you're asking me to explain electromagnetism using electromagnetism. It's circular, can't be done. It's like trying to explain the color blue to someone blind from birth. You can talk about wavelengths around 450 nanometers. You can describe where it sits in the spectrum between red and green. You can give them all the physics of blue. But none of that conveys the experience, the actual blueness. They have to see it. There's no shortcut. Same with magnets. Same with electromagnetism. You don't get the intuition from an analogy. You don't get it from a 5-minute explanation. You have to earn it. So, what can I give you? The technical answer. Magnets have magnetic dipole moments, little arrows of magnetism. When you align millions of them in the same direction, you get a permanent magnet. Those dipoles create a magnetic field configuration that stores potential energy. Physical systems naturally evolve toward lower energy states. When two north poles face each other, the energy is high. Moving them apart lowers the energy. So they repel. That's the answer. That's as deep as it goes. You want to know why dipoles create fields? I can tell you about moving charges and electron spin. You want to know why electrons have spin? I can tell you about the Dirac equation and quantum mechanics. You want to know why the Dirac equation is correct? I can tell you it follows from combining special relativity with quantum mechanics. You want to know why those theories hold? Because they match reality. Because we've tested them millions of times and they work. That's it. That's where the chain ends. Here's what you need to understand about how physics actually works. We don't start with philosophy and derive the universe. We start with measurements. We observe patterns. We write equations that describe those patterns. We test those equations against new experiments. When the equations work, when they let us predict things we haven't seen yet, we say we understand the phenomenon. Understanding in physics doesn't mean philosophical satisfaction. It doesn't mean matching your intuition. It means predictive power. By that standard, we understand electromagnetism better than almost anything. We can calculate the force between magnets. We can predict how they'll behave in different configurations. We can design electric motors, generators, MRI machines, particle accelerators. That's real understanding. That's what physics offers. Not comfort, not familiar analogies, but power, control over nature. So pick up those magnets one more time. Feel that invisible push. Now understand. You're feeling one of the 4 fundamental forces of nature. The same force that makes chemistry work. The same force that makes stars shine. The same force holding you together right now. That's not mysterious. That's magnificent. And the fact that we can describe it with equations, test it with experiments, and use it to build technology, that's not a failure to explain. That's what understanding actually looks like. The universe doesn't owe you an explanation that makes you comfortable. It doesn't owe you a story that matches your intuition. Your intuition evolved to throw rocks and pick fruit. It did not evolve to understand quantum fields. So when physics reveals something that violates your intuition, you have 2 choices. You can reject it as mysterious and unsatisfying. Or you can expand your intuition, learn the mathematics, build new mental models. That's what physicists do. And that's why we refuse to explain why magnets work. Because the kind of explanation you want doesn't exist. But the truth? The truth is so much better.